Okay, so in our video today, we are going to be talking about how to balance chemical equations using the best method ever. Now, this method is called the best method ever because my students love this method so much and it leads to desired results. Now, this is my second video on balancing of chemical equations. If you want the link to my first video where I practicalize the very first method of balancing equations, which is the trial and error method, you can see the link on the description. The link is found in the description. Do well to like this video, do well to share this video, do well to subscribe because I'm going to be exposing you to the best method of balancing chemical equations. Now, this method, like I called it, the best method ever, it involves the method of mathematical equations. Now, what are the steps involved in this particular method? Now, these are the steps. The very first step here, step 1, you have to first of all write out the unbalanced equation. That is the very first thing you have to do. The second thing you have to do is you have to assign coefficients in alphabetical order to all the components in the equation. For example, how many components are there in this equation? We have 1, 2, 3, 4, and 5. So the number of components present in the equation determines the number of alphabets you are going to assign. For example, since I have 5 components in this equation, I'm going to assign the coefficients A, B, C, D, and E. Starting with, I'm assigning A here. I have A. I'm assigning B here. I'm assigning C here. I'm assigning D here. And I'm assigning E here. These are my coefficients. So I have done the very second step, assign coefficients in alphabetical order to all the components in the equation. Now the next thing I'm going to do here, I'm going to construct the linear equation using the coefficients. And it's done this way. For example, I'm going to single out all the elements present in this equation, starting like this. The first element I have here is iron, which is Fe. Now for the iron I have here, I'm going to bracket it. How many iron atoms are here? I have just 2 atoms of iron. And I don't have any other iron on the reactant side. No other iron, no other iron. So I'm going to say 2 multiplied by A is equal to what? 2A. So since there is no other iron atom on the reactant side, I'm going to put an equality sign equal to, let's go to the product side. How many iron atoms am I having here? Just 1. 1 times D is equal to D. So I have 2A is equal to D. So considering the element iron, I've gotten just one single equation here. And I'm going to call this equation 1. Let's consider the second element I have here, which is sulfur. Now the sulfur atom I have here, let me write it in brackets, sulfur. All right, how many sulfur atoms am I having here? I have just 1 sulfur atom, but there is a bracket. Now the bracket, outside the bracket I have 3, which means I have total of 3 sulfur atoms. That's 3 times 1 equal to 3. So sulfur atoms 3. So I'm multiplying the 3 by the coefficient, which is A. So I'm going to have 3A. I'm going to check, do I have any sulfur atom on the reactant side again? I don't have any other one. So I'm going to say this is equal to, on the product side, I have just 1 sulfur atom here. And the coefficient here is E. So I'm going to say 1 times E is equal to what? E. So I have 3A is equal to E. So this is my second equation. I call this equation number 2. Now I'm going to pick out the next element here. I'm seeing oxygen. So I have my oxygen. So the oxygen here, I have 12 atoms of oxygen. Because in the bracket I have just 4. Then 3 times 4 is equal to 12. So 12 times A, I have 12A. Okay. Do I have oxygen atoms on this other side? Yes, I still have oxygen atom on the reactant side. And how many oxygen atoms am I having here? I'm having just 1. So 1 times C is equal to C. So I'm going to say 12A plus C. because I'm still having the same oxygen on the same reactant side. So now let's go to the product side. I'm going to introduce an equality sign equal to. On the product side, I have oxygen atom in bracket is 1 and there's a 3 outside the bracket. So I have 3 times 1 equal to 3. So 3 times the d outside, which is the coefficient, is equal to 3d. I have 3d. Do I have oxygen atoms again? Yes, I have them here. So I say plus. How many oxygen atoms are here? I have just 4. 4 times E is equal to 4E. Okay, if you're finding this a little confusing, try to take your time to single out the number of atoms before you can start doing this. Okay, moving on. This is my equation number 3. I call this equation 3. Now moving on to the next equation. Okay, moving on to the next equation. The next equation will be coming from the next element I have here, which is nitrogen. So I'm going to say nitrogen in bracket. So for nitrogen in bracket, I have nitrogen here, which is just 1. So I'm going to say B, that's 1 times B is equal to B. And there is no other nitrogen on the reactant side, so I will say this is equal to. Coming to the product side, I have nitrogen atom here, just 1 inside the bracket, but outside the bracket there is a 2. So 2 times 1 is equal to 2. So I have 2 nitrogen atoms here, and the coefficient is E. So 2 times E is equal to what? 2E. So B is equal to 2E, and this is my equation number 4. What is left? What is left here is the next atom, which is hydrogen. Let's check hydrogen out. So for hydrogen here, I have 3 atoms of hydrogen here. So I'm going to have that's 3B. So 3B, there is no other hydrogen. There is a hydrogen on this other side. So that is 3B plus 2C. Plus 2C is equal to, going to the product side, I have 3 hydrogen atoms here. 3 times 1 is 3. So 3 times this 3D. 3D plus, there's a hydrogen atom here. That is 2 times 4 is 8. You have 8E. So this is my equation number V, equation number 5. Now, this is how to extract all the equations. Now, this took me quite some time because I was just trying to make sure you understand what I'm doing. But under normal circumstances, extracting all these equations will take me just 30 seconds. And by the time you get competent with doing this, it will take you still 30 seconds or less than that. So these are all the equations we have. Now let us solve the equations. So to solve these equations, remember the next rule here says, assume that one of the coefficients is equal to 1. Before you can make this assumption, you have to make any of the coefficients here to be equal to 1, but make sure that the one you're making, the one that you're equating to 1 must be the one that is very convenient. For example, if I make my A to be equal to 1 here, I'm going to say 2 times 1 is equal to what? D. That one is very convenient. So can we try it out? Let's try. So I'm going to say, let A equal to 1. Because I've seen is the most convenient one for me to do. So A is equal to 1. So if A is equal to 1, I can now say that from equation 1, 2 multiplied by 1 is equal to what? D. Hence, D is equal to 2. So I have 2 parameters so far. I have A is equal to 1 and D is equal to 2. Moving on to the next. What is the next coefficient I can easily find without stress? Now, I have my A equal to 1, so I can easily find E from here. So therefore, since my A is equal to 1, I can substitute A into equation 2 to find my E. So what do I do? So I will say 3 multiplied by 1, which is A, is equal to what? E. So therefore, E is equal to 3. Moving on. So I have A, I have D, I have E. So which other coefficient can I easily find from here? I can easily find my B because I know my E. So I can substitute the value of E in equation 4 and I can find my B because I know that B is equal to 2E. So I can now say that B is equal to 2 multiplied by E. E is equal to 3. So in bracket I have 3. So therefore B is equal to 6. Can we move on now? All right. So how many coefficients do I have so far? I've found A to be 1. I found D to be 2. I found E to be 3. And I found B to be 6. Which coefficient is left out so far? I have the coefficient C. I haven't found C. What can I possibly do to find C? I can either use equation 3 to find C, or I can use equation V to find C. So let's use equation 3, any of them. I want to use equation 3. So I'm going to make my C the subject of the formula. Hence, C from there is equal to, this is my C. C is equal to, I have 3D plus 4E. Then I'm taking the 12A to the other side. It becomes minus 12A. Let's do this together. So my C is going to be equal to, what is my D? D is equal to 2. So 3 bracket 2 plus 4 bracket, what's my E? E is 3. Okay. All right. Minus 12 bracket 1. Let's figure this out. So this is equal to 6 plus 12 minus 12, which is equal to 6. So these are my coefficients. So I have that my A is equal to 1, my B is equal to 6, my C is equal to 6, my D is equal to 2, and my E is equal to 3. So putting these coefficients back into the equation makes the equation balanced. Hence, we now have 2 moles of Fe2SO4 bracket 3 plus B is equal to 6, so 6NH3 plus 6H2O, because my C is also equal to 6. Then I now have 2FeOH bracket 3 plus plus I have NH2 bracket, so that's NH4, sorry, NH4 bracket 2SO4. Then what I have outside here is 3. This is my balanced equation. You can take your time to count the number of atoms on both sides of the equation. Then you can see that the equation is balanced. We have ended up using all the steps here. Assume that one of the coefficients is equal to 1. We've done that. Solve the equations, then obtain the values of the coefficients. We have done that. So you can try this same approach using the following equations. Okay, let's go through the following exercises to see what we've done so far. So these are equations. I would like you to take your time, balance these equations using the last method we just considered. This is the equation between, this is calcium phosphate reacting with silicon 4 oxide to give you phosphorus 5 oxide and calcium triazosilicate 4. Yeah? So this is just check out all these equations here, balance them using the method we just discussed. Now feel free to like this video, share this video with your friends. Chemistry is quite interesting. Share with your friends, subscribe to my channel. It will help you to grow your chemistry career. See you in our next video where we'll be talking about stoichiometry and how to deal with calculations on stoichiometry.